Welcome all the viewers. Today topic is lean manufacturing system. What is lean? Lean means a manufacturing systems where all the waste are eliminated. Why this is necessary? Why we talk about the lean manufacturing systems? In today's competitive world, we have to be cost competitive. And lean manufacturing systems is an operational excellence strategy. We can excel for better tomorrow. If we do not compete in today's time, we cannot be successful tomorrow. Because here customers are paying you only for the value added by your company, not for the waste generated by your company. So in this topic, we will discuss what is the lean manufacturing, what are the type of waste, what should be the ideal structure of the lean manufacturing systems. And if we see the major manufacturing waste, and we will say that these wastes need to be eliminated, then we can foresee what is the lean manufacturing systems where no waste will be there. But in the outset, I will like to say that no system is 100% perfect. It needs continuous improvement. Therefore, even if we say that it is the lean manufacturing systems, so we cannot say that there is no opportunity or no options for improvement. There is always. Kaizen is one of the theory, one of the technique of the lean manufacturing systems, which always believe that a small amount of changes should be there in this process, so that on the cumulative basis, it has a larger impact. Now we move to the lean manufacturing systems. Here, we are talking about the waste which need to be eliminated from the system. We can think of an example. Suppose the price of a product is 100 rupees and cost of the manufacturing is 90 rupees. Then profit is 10 rupees. If you want to increase the profit of the company from 10 rupees to 15 rupees, what are the options? Simply, we can say we will increase the sale price from 100 rupees to 105 rupees, and cost will be the same, 80 rupees. Then the profit will increase from 10 rupees to 15 rupees. Is this viable? In today's competitions, it is not viable at all. Why? Because there is a competitions. Your competitor will also be offering the same product. You cannot go out of market. If your competitor is selling at 100 rupees, you cannot sell at 105 rupees. You can sell at 105 rupees provided you have some quality or premiumness in your product. If your product is similar to your competitor, your price will also be 100 rupees. Then how we will increase our profitability? There is only one option, that we have to reduce our cost. How to reduce our cost? That can be achieved by these waste elimination process. Now we will come to each process separately, how we can reduce the waste. And when we will focus on each and everything, we will come to know how these are impacting our production cost. And by eliminating some part of this, we can reduce our cost. Here, I would like to tell that it is not for the engineers only that they should study about the lean manufacturing. It is for the accountant also. It is for the general public also, so that they will have some good idea of what is lean manufacturing. And in today's economy or today's knowledge world, specialized knowledge is not necessary. Specialized knowledge can be done by computers only, because we have to define the principles of specialized knowledge, and those things can be done by computers. We, as a professional, need not enter into that area. Then why we take a lot of knowledge? A lot of knowledge is the contextual knowledge. Here we know each and everything, what is happening in other industry, how it is impacting, what one set of knowledge is doing to the other set of knowledge. For example, I give you the example. In one of my projects, when I was doing the retail strategy, how to expand the network, how to improve the sale, and how to reduce the inventory. At that time, being familiar with the FMCG company and being worked and having worked in the area of brand management and business strategy, what type of product we should do, what is the brand customer loyalties, etc. Their marketing is a separate vast subject, but still I have worked on that area, therefore I know a lot about the marketing. I have also worked with the various consultancy firms where we have reduced our cost. We can and improve our profit from 50 crore to 100 crore, just double the profits. So when I was young and when I was dealing with the consultant, I was also not aware that these are the techniques which can reduce the cost. And ultimately, when I see the different type of knowledge, then I come to the conclusion that these are possible. And although I have done in the past, but I think this type of knowledge should be there. Now I come to the next slide. Here, first waste, we are saying that the wastage is transportation, defects, overproductions, overprocessing, waiting, motions, inventory, and unused talents. Now I will come to each type of waste, and we will see how it can be reduced. First waste is the transportation. Generally, I have seen, and you would have also seen, that in every company there is a warehouse where all the raw materials comes, all the stores, spares comes, and then these are given to the shop floors. And from shop floor, there are multiple manufacturing unit. We can say one make the intermediate product, and second from the intermediate product to finished goods, etc. And these finished goods are sent to the finished goods store, and finished goods store it goes to the customer. So there is a lot of handling in between. First, the material is unloaded by the warehouse, and when this is needed by the soft floor, then this material is sent to the soft floor, involving some movement. Then from soft floor, intermediate manufacturing, it goes to the finished goods sections where it is made a finished goods. And from after finished goods, it goes to the finished goods warehouse. And in some case also, I have seen in the FMCG companies that finished goods warehouse, which is in the within the company, it goes to the mother warehouse. And from there, it goes to the customer. And before going to the customer, it goes to the wholesaler to retailer, and then customer. Then these are the movements. We have to see How to reduce these movements? There are a lot of techniques because now there is a lot of advancement in the technology. So there is a lot of improvement opportunities. Some of the company, which are the big automobile manufacturer, they have implemented GIT systems. What this system is, they are not getting the parts or raw materials in the stores, raw material stores. They are getting only on the shop floor whenever they need it. Suppose their production of a particular car is going on in the shop floor, they will ask the vendor to deliver the part of that car only at the shop floor, so that they can eliminate the movement. First, getting it in the warehouse, and second, getting at the shop floor. This is a huge saving, but we have to see what its impact is. First, it eliminates the inventory, and second, it reduces the movement and reduces the manpower cost. And third, there is a wastage during the transportation because some parts got damaged. So this all can be eliminated by this single step. Therefore, JT is also one of the technique of lean manufacturing. Further, there is a Kaizen, which talks about continuous improvement in quality and continuous improvement in cost also. There the target is fixed, and once it achieved, then again target is fixed for reduction in the cost. Therefore, the same technique can be used here. We have to say that these are the movement which is happening from the warehouse to shop floor. Now, how can we eliminate? If we cannot eliminate, then we can think of reducing by how many percentage? Suppose it is 100% currently raw material is coming in the warehouse and then going to the shop floor. Then we can say that we will try to reduce it to 60%. Then after achieving 60%, we will again say, okay, we will try to reduce it again by 60%. Then what will happen? It will reduce this wastage to 64% and keep the waste cost only 36%. But still 36% is a use cost which we have to eliminate. Therefore, there should be process of identifications, and then effort should be made to reduce it and ultimately eliminate it. Similarly, in some industry, I have seen then raw material comes and then is stored in the tank. It is not stored in the warehouse, it is stored in the tank, where from through the pipeline it goes to the shop floor. This is a good system because here the movement is not there, but movement is still there. It is going from the pipeline to the production floor. But how this can be eliminated, that has to be seen. And there should be a continuous study on this. And even there is a movement of the goods between shop floor and in the shop floor between the intermediate product and the finished goods. This is particularly in those industries where there are two separate blocks, one for manufacturing intermediate and one for manufacturing the finished goods. And intermediate are moved to the finished goods. Why should it be done? It can be eliminated by keeping those two machines side by side, or by making the layout in such a way that there is no movement or very less movement. Similarly, why to send to the finished goods store? Why cannot it directly be lifted from the shop floor through the cranes, overhead cranes, or some other medium? And even to the customer, there is a cost of transportation, and this cost can be eliminated by bigger truck or by combining the delivery to a particular route. And this is a supply chain topic, and most of the companies are doing this. But also this is a part of the lean manufacturing, ultimately reduction in the cost. And I have seen in companies without this technique was incurring a huge cost, and their transportation cost can be reduced by 10 to 20%. In this area, there is a lot of improvement possible. We can reduce our cost, but we need a focus. Now we come to the next waste. That is the defective part. Here we have said that we have to reduce the waste because every waste has a cost. Some we count, some we do not count, but we should count all the waste. Even in some industries, I have seen that full cost of waste is not computed. And if full cost of waste is not computed, then we take inappropriate decisions. We give the example, production is 100 metric ton per day, and after QC, it is only 80 metric ton per day. 20 metric ton is the waste. We can say the cost price of this is 100 rupees per kg, and selling price is 110 rupees or 120 rupees, we can say, and 20 rupees is margin. Then one approach will be 100 rupees per kg is wasted on 20% of the production. Then it will be 20 rupees waste cost, less the cost of the recovery. Because if this material is sold, then we will get something. And if we get around 10 rupees, then this waste cost is 10 rupees. This is one of the approach. But this is not correct. Here we are losing not only the cost of producing the waste, because in addition to it, we are also losing certain other things. What are those? We are wasting the power. Power is being utilized. If we allocate it on 100 rupees, then it costs 7 rupees per kg. And if we allocate on 80 rupees, then it will not be 7 rupees. It will more than 7 rupees. Or we can say, even on this wastage, we have incurred the power cost, which we have to consider as a waste. Because customer cannot be loaded with this extra power cost due to the waste. Similarly, there is labor cost. Similarly, there are indirect overhead, which are incurred in the company. Similarly, there is a loss of contribution, because 20 rupees is the contribution on every production which we have lost. That should also be counted in the waste cost. Therefore, simply saying that waste is has reduced from 20 metric ton or 20% to 10% and we have reduced the cost by this, only considering the raw material cost, is incorrect statements. Therefore, I say that in every problem, we have to find the true cost. And if we can identify the true cost, we can take correct decision to reduce it. If we cannot, then we cannot reduce. Now we come to the overproduction. What is the overproduction? In the image, you are seeing that there is a lot of productions capped on the table, etc. Everywhere is there. This is the overproduction. Why this overproduction happens in the company? Since I have the practical experience of seeing this in the company, I know there are a lot of reasons. Suppose a customer is demanding only 30 metric ton and the best size is 40 metric ton. Then we have to produce 40 metric ton. And what will happen of this 10 metric ton? This will be the overproduction, which will be kept in stores. Then what should be the strategy? Then the strategy should be to combine the order of similar type of customer and come to the optimum size. Suppose there are two order of 30 metric ton, 30 metric ton, and then this is 60 metric ton. Then instead of taking separate run for 30 metric ton and 30 metric ton and producing 20 metric ton waste, we can run a single batch of 60 metric ton. Because the batch quantity is higher than 40 metric ton. This is called combining the order and production planning. But this is not only the single problems. There are also other problems. We have the unreliable process. We do not know what will be the amount of waste. In the earlier example, there was 20% waste. And we have to take out this 80 metric ton, then we have to run 100 metric ton. But we are not sure whether this 20 metric ton will be 20% waste will be there. It may be 25%. Then if we have to supply to the customer 80 metric ton, then we have to take production of more than 100 metric ton. And if the actual wastage come down, then there will be the overproduction. Suppose it is 10%, then the actual production will be more than 90 metric ton. Customer is requiring only 80 metric ton and we are producing 90 metric ton. This is the overproduction. And this is also a waste because customer is not demanding it, and this will be kept in the store, finished goods store, where this will be demanded by some other customer at some other point of times, if it is not a regular run. Because I have seen in the industry that there are different specifications by the customer, and each product has to be made on the different specifications. Then we have to see and find out that customer which have the same specification, and until then it remain in the warehouse and waiting for the order from the customer. And if we pressurize the sales team for this type of order, they will come and say that X customer is ready to buy this and they need certain discounts. Therefore, this is the area which is the production planning area and the process control area also, where we have to make effort to avoid this overproduction. Overproduction is 100% waste, whether it may be due to any reason. And in the industry, my experience and even in the industrial knowledge, we know that most of the overproduction is done by the company itself. They knowingly do it, and this has a cost. So this has to be, this cost is also not customer is also not going to bear. Then next is the over processing. What is the over processing? Customer asks a certain specification, and we say that we have to be more quality conscious, and we have to over process that things, and then send the material to the customer. For example, in the ink industry, I give the example. Customer is asking for a certain type of ink. Ink is perfect, but we say, no, our quality should be the best. Therefore, instead of adding 5% pigmentation, we add 6% pigmentation. What will happen? It will give better color, better thing, better mileage, but your cost of production has increased per kg. Simply, we can also give example in another area. Customer is asking a computer with 8 GB RAM, etc., normal situations, but we build certain extra features in that computers, which is not required, because certain motherboard is required to manage that computer. But we are saying that it may be possible that customer in future will go for the extension of this computer from 8 GB to 16 GB or 32 GB. So our motherboard should be capable enough for that also. That is the future ready, and for that we make extra cost, what we can say 5,000 rupees. So why customer will pay that 5,000 rupees for being the future ready? Therefore, we should not over process. We should make the product as per customer specifications, and over processing or over specifications is also a cost. Now, the next most important waste is the waiting. Why the waiting occurs? I have given this example. The man machine is producing 100 metric ton per day, but the next machine capacity is 100 metric ton per day. Then what will happen? Second machine will remain idle because the input is 100 metric ton and they are capable of making 115 metric ton. Therefore, some hours it will be shut. What does it mean? It means capacity is not balanced. If capacity is not balanced, this type of things will occur. Second machine will keep on waiting for the goods, but not receiving the goods. Then second machine will not be 100% efficient. Their cost of production will be higher compared to when it will be 100% efficient. Another example, this is one of the line balancing. Another example of waiting is when the material available in the store is only 50 metric ton and the first machine capacity 100 metric ton per day. Material is not available in the store, so it cannot run. So it is waiting for the material. This is also a waste because 50% capacity is lost due to no material. Similarly, there may be situation that labor are not available, skilled manpower not available, power is not available. So we should eliminate these type of waste, whatever is possible, because 100% perfect process cannot be designed. So at least 95% should be there. Now we come to the motion study. Here I remember F.W. Taylor. F.W. Taylor was a mechanical engineer in US, and he has written a book, Principle of Scientific Management, in 2001, in which he elaborated a lot about the time and motion study. And there is a separate field of industrial engineering, which focus on what is the moment, what is the process time, how to reduce the process time, and how to improve the efficiency. If in any machines we keep on checking, if we stand side by side, side of a machine, and see the performance of the machine, and we keep taking note of this, we will come to know what is the performance of this machine. Similarly, the industrial engineer, they study the process, they study the motion, okay, how the material is moving, what is the motion of movement of the workers, etc. And based on that, they find the motions which are not suitable or which are not required, and cut those motions and improve the production. I can give you the simple example in the accounting department. There is a CFO. His all department should sit in front of him. Suppose he want to talk to the tax persons. So tax persons is in the next floor. So he has to go to the next floor to meet the tax persons. So this is the unnecessary movement. Similarly, there is the account head, which has to talk about his accounting team. And accounting team is spread, not in one position, not in one location. Then he has to talk to some persons, so he has to move to some other person or call that person. And in both the process, there is a wastage of time. So why to do this unnecessary motions? We have to eliminate these unnecessary motions. And there is a good example of scientific management by Henry Ford in his production line. And they have made the production line so efficient that the cost of production of the car which they have produced is the lowest. And by that, he became successful in US for his car. Next example is the inventory. Why should we keep the inventory? If it is JIT system, then inventory will come to the shop floor, not in the warehouse. And I have seen the cases, even when there was the inventory, production was not happening because a particular material which is required for the production is not available. Other material are available. Then what the use of this inventory? If it cannot protect the sale, therefore, there should be a proper inventory management, and only those goods should be in the store which is required to protect the sale. And other unnecessary things which are in the stores lying for years should not be part of inventory. And that is, those are waste. And we are keeping in the stores. We are keeping the costly space and human resources to track those things. Even if we take the reports, it comes in the reports, we have to analyze. And cost of inventory is also something which is will go as a waste if it not used. Therefore, inventory management, which is a part of the supply chain, ultimately is to ultimate objective of supply chain is to keep the minimum inventories which is required to protect the sale and make the plant continuously running. If JIT system is not followed, if JIT system is followed, then why to keep the inventory? As I told earlier, 100% perfection is not possible. Therefore, keep some inventory, but to the minimum level. And this is the lean manufacturing. After studying all the slides, we have come to the conclusion that there are a lot of waste. We have to eliminate those waste, and we have to come to the lean manufacturing. And what lean manufacturing means, waste will be reduced or eliminated. There should be systematic flow. Okay, how the material should move, what should be the motion, how the inventory should be managed, and there should be pull system instead of push system. Pull system means everything should be planned based on the customer order, and we have to focus on the customer order for every planning. Further, we should map our value systems. What is the value we are giving to the customer, and accordingly we have to plan. If we are in inventory, we are keeping the inventory that is not giving any value to the customer. Customer interest is only to receive the goods. They are not going to pay you for the inefficiency and the resulting wastage. So we have to map our value system. What is the value we are giving to the customer, and what is not the value to the customer? We have to reduce or eliminate that. We have to go for perfection. Perfection is the 100% improvement, but that is not practically possible. We have to come very close to the perfection, and even if we make the system 100% perfect, but due to the new technology, new knowledge in the fields, very soon we will see that there is a lot of possibility further in the 100% perfect life. And ultimately, we have to define our value. What is our value which we are giving to the customer? And this is the lean manufacturing. And after the end of this lean manufacturing systems, what will be the impact on our organizations? We will definitely need less material because of reduction in the wastage. Because now 100% input will be used for 100% output instead of 100% input we use and make out only 80% and 20% is the waste. We will need less investment in the machineries, in the warehouse, or in the process, because our line will be balanced. We will be keeping less inventories. We will be able to reduce our cost because we will be eliminate our waste, non-value added things. We will be keeping less inventory because we will be implementing the pull systems. And in pull systems, we will be keeping inventory just for the order of the customer. We will be going for the lean JIT systems, Kaizen systems, and we will also requiring less people. Less people does not mean reduction in the manpower. It means less people are required due to the nature of the process. Nature of the process means eliminating unnecessary motions. And if we reduce the unnecessary motions, then the time spent will be reduced. We will be using better technology for the repetitive task instead of manual things, etc. By the motion is by studying the motion study, etc. And some of the technique which I have discussed during my brief presentations was uh, just in time. This is consistently being used by all the auto manufacturers in India. Kaizen costing, which is the continuous improvement. First target is reduce the cost by 20%. And after achieving this target, suppose the target achieved is 18% instead of 20%, then next year 82% become the target, and from where the further cost reduction is taken. Similarly, there is a 5S, TPM, Six Sigma, and the cellular manufacturing. These are separate tactics for which we need separate time for discussions. And if I discuss here, the length of the video will be very lengthy, which I do not want. I want to focus only on the elimination of wastage. Thank you. And being once again, I thank you for being part with me. Thank you.